All right, let's get into it. Today, we're not just deploying a system, we're building a digital fortress. We're going to lay out the entire blueprint for a perfect VxRail deployment, showing you exactly how to sidestep those common traps that can completely derail a project before you even get started.
And let's start with the single most important idea. Deploying VxRail is just like building a house. Seriously. You would never, ever start pouring a foundation without a detailed blueprint, would you? Of course not. The same exact rule applies here. Planning isn't just a nice-to-have. It's everything. So here's our game plan for this project. We're going to start with the blueprint itself. Then we'll pour the network foundation. After that, we'll frame out the storage and management. Throw in some high-performance upgrades, check the digital plumbing, which is our DNS, and then we'll do one final inspection before we go live.
Okay, first things first, your VxRail blueprint. This is all about nailing down the core strategy before you even think about racking a single piece of hardware.
So what are we even talking about with deployment planning? Well, it's that crucial first step where you map out every single detail. Your network, your storage, your compute, all of it. And the goal is incredibly simple, but so important. You want to eliminate the errors that can stop you in your tracks, and you want to squeeze every last drop of performance out of the system from day one.
Now, let's talk about the network foundation. Look, if planning is the blueprint, the network is the literal ground you're building on. If you get this part wrong, the whole structure is wobbly from the get-go.
And that foundation rests on three non-negotiable pillars. First, you need separate, independent IP address ranges for all your different traffic types. Management, vSAN, you name it. Second, you absolutely have to use VLANs to keep all that traffic neatly segregated. And third, those critical switch settings like jumbo frames and port fast, yeah, they're not optional, they are 100% essential. And speaking of essentials, here's a hard and fast rule you just can't ignore. Every single VxRail node has to have a minimum of two 10 gigabit Ethernet ports. This is not a suggestion, it's the absolute baseline to make sure your system has enough bandwidth to breathe.
And please don't forget about the little details that make a huge difference. Case in point, jumbo frames. Just by changing that one setting, the MTU, or maximum transmission unit, to 9,000, you're allowing much bigger chunks of data to move at once. This gives you a massive performance boost for storage and live migrations.
And here's another one that people forget: time. In a big distributed system like this, every single node has to agree on the exact same time, down to the millisecond. Why? Because if they don't have a single source of truth from an NTP server, your logs become a useless jumble, and you can even risk data corruption. It's a non-negotiable for a stable cluster.
Okay, our foundation is solid. Now it's time to start framing the house. This part is all about the big architectural choices you have to make for storage and management. And your first major choice is storage. Are you going to go hybrid, mixing speedy SSDs for cache with big, spacious hard drives for capacity? Or are you going to go all in on performance with an all-flash setup? You know, there isn't one right answer here. It really just comes down to your workloads, your performance needs, and, of course, your budget. Next up, who's in charge? The vCenter is the brain of this whole operation, and you've got two main choices. For brand new self-contained deployment, you can just use the vCenter that comes built right in. Super simple. But if you're in a bigger company, you're probably going to want to plug this new VRail cluster into the existing vCenter you already use to manage everything else.
All right, for those of you who aren't just building a house, but are aiming for a skyscraper, let's talk about some next-level performance upgrades. This is where we get into some really cool high-performance architecture.
So let's talk about RDMA. I want you to think of this as a private, super-fast express lane for your data. It lets your servers write directly into each other's memory, completely cutting the CPU out of the conversation. This doesn't just lower your latency, it absolutely slashes it. It's like strapping a giant supercharger onto your vSAN storage.
But hold on, you can't just flip a switch and get RDMA. The requirements are pretty strict. You need a seriously fast network. We're talking 25 gigabit or higher. You need special network cards that can handle what's called ROSI v2, which is just RDMA over Ethernet. And your switches need to support advanced features to prevent data loss and manage traffic jams. It's a high-performance feature, and it definitely comes with high-performance requirements. Sticking with modern architecture, let's compare the classic vSAN, known as OSA, with the new kid on the block, ESA, or Express Storage Architecture.
The single biggest thing to know here is that ESA gets rid of the dedicated cache disk, which was honestly a bottleneck in the old model. With ESA, every single drive pulls its weight and contributes to performance, which makes it way more efficient for modern all-flash systems.
Okay, we've got the frame up and the high-performance systems are in. Now it's time for the utilities, the digital plumbing and electricity. I'm talking about DNS. And trust me, if you got this wrong, the whole project can fail spectacularly. So, let me ask you this. What do you think is the #1 reason a VxRail deployment fails? Is it the expensive hardware? The complex networking? Nope. More often than you could possibly imagine, it's something as basic as DNS.
But why? Why does DNS cause so many headaches? Well, you have to remember that every component in this cluster is constantly chatting with every other component by name. So if a node can't find the vCenter by its name, or if the vCenter can't confirm a node's identity by looking up its IP address, the system just panics. It sees it as a total communication breakdown, and the deployment stops cold.
We are so close to the finish line, it's time for our final pre-flight check. This is our last walkthrough to make absolutely sure that every single detail in our blueprint has been followed to the letter.
And this all boils down to one simple idea. Validate everything before you click that deploy button. Make a master list of all your IPs and VLANs. Draw a quick network diagram so you can see how it all fits together. And please, use the official network validation tool. Test your DNS, both forward and reverse lookups, for every single component. This final checklist right here is your key to a smooth, stress-free launch. So, there you have it. Your blueprint is complete. The plan is solid. But that leaves us with one final and really important question. Is your infrastructure truly prepared for what you're about to build on top of it?